Diesel cycle. The diesel cycle is the thermodynamic cycle which approximates the pressure and volume of the combustion chamber of the diesel engine, invented by Rudolf Diesel in 1897. It is assumed to have constant pressure during the first part of the combustion phase, V2 to V3 in the diagram. Process 1-2. T2 over T1 equals RV power of gamma minus 1. P2 over P1 equals RV power of gamma. Q12 equals 0. Process 2-3. Q23 equals Q equals MCP times T3 minus D2. T3 is a Tmax of the cycle. Cut-off ratio. Beta equals V3 over V2 equals T3 over T2. Process 3-4. T4 over T3 equals beta over RV power of gamma minus 1. P4 over P3 equals beta over RV power of gamma. Process 4-5. V4 equals V5 equals V1 equals VBDC. Q45 equals Q out equals MCV times T1 minus D4. Process 5-6. P5 equals P6 equals P0. W56 equals P0 times V6 minus V5, and lastly is determined thermal efficiency. Efficiency equals 1 minus Q out over Q in. It is similar to the Otto cycle, but you need to remember that formula for Q in is different. Now let's see the example solution for diesel cycle question.
An ideal diesel cycle has a compression ratio of 18 and a cutoff ratio of 1.5. Determine the maximum air temperature in degrees Rankine and the rate of heat addition in BTU per hour to this cycle when it approaches 200 horsepower of power. The state of the air at the beginning of the compression process is 13.8 pounds per square inch and 65 degrees Fahrenheit. Assume the cold air standard applies for this problem. Draw the PV diagram. Let K equal 1.4 for air. The first step in solving this problem is to write out the known values of compression ratio R, cutoff ratio RC, temperature at point 1 T1, pressure at point 1 P1, and the ratio of specific heats K. Next, we will draw the PV diagram labeling points 1, 2, 3, and 4, as well as the location of top dead center and bottom dead center. In order to find the maximum air temperature, the value for the temperature at point 2, T2, must first be calculated using the equation T2 over T1 equals V1 over V2 to the K minus 1. This equation simplifies down to T2 equals T1 times R to the K minus 1. Now the maximum air temperature, T3, can be calculated using the formula T3 equals T2 times RC. To calculate the rate of heat addition, the thermal efficiency of the diesel engine must be found using the equation eta Th diesel equals 1 minus 1 over R to the K minus 1 times RC to the K minus 1 divided by K times RC minus 1. Finally, to find the rate of heat addition to the cycle, we will use the equation eta Th equals W dot net divided by Q dot N, where W dot net is the power produced by the cycle and Q dot N is the rate of heat addition. Solving this equation for Q dot N, we get that Q dot N equals W dot net divided by eta Th, which will allow us to solve for the desired value for the rate of heat addition.